Hi guys, and welcome back to Big to Small. Today we got it all. Today we have a special guest named
Kale the chemist.
and I'm here. What's my name?
Sabrina the space head.
Can chemistry explain why we had the Ice Age?
Some, yeah.
Explain. Maybe I can teach you how.
Great.
Do you know what type of rock this is?
I do. It's limestone.
Oh, limestone is one of my favorite types of rocks. Did you know that, Kale?
I didn't know that.
Here, take it.
Sabrina.
Now,
Is that water?
no. In fact, this is one of your favorite chemicals, Kale.
Is it an acid?
Oh, yeah. It gets better.
Better?
It's acetic acid.
Oh,
But,
no.
Sorry, it's diluted.
Oh, good.
Yeah. So,
Safety first.
so guess what? Here's something crazy. There are stories in these rocks. Can you read it?
No, I can't hear the stories either.
Oh, okay. So guess what? If you put a little bit of acetic acid and just put it on the rock, it will start to disintegrate.
Oh, wow.
Can you believe that?
That's awesome.
And guess what? In there, you can find especially crazy things. These are shells from now that I found at a beach in Florida, but you can find shells in this Minnesotan rock.
Wow. Why would shells be in Minnesota?
That is a great question.
Thank
And
you.
that is where the Ice Age comes into perspective. I know it's not the Ice Age, Kale, okay? I know. But it has something to do with how our world temperature has patterns. The Earth, I know because I've been to space.
Hmm.
So
Yes,
I can
Sabrina, you have.
I can just show you. The Earth doesn't just stand like this. It's always at an axis. Right?
Yeah, you can lean on me.
Oh, thanks. But sometimes it wobbles. Okay, give me a little push. A little push. Give me a little time. Oh, not that much. It's just like this. Doo-doo, doo-doo, doo-doo. And then it moves in a circle. Keep going. Doo. Like this.
Are you oscillating?
Oh! Yeah. Good one, Kale.
As it bounces, it gets closer and farther away from the sun. That is the, drumroll please, Milankovitch cycle. And that temperature change of more radiation coming onto our planet is because of the radiation being absorbed and having more energy for those gases. So those gases are moving faster, and that is what's creating heat.
When it's farther away from the sun, less energy can get to it, meaning that is why it was colder during the Ice Age. Also, you can tell in the rocks that the world changes. This is one example.
The planet didn't always look exactly like this. Plate tectonics moved these things around. And once, here, let's turn the US, even the US was underwater. What? That's crazy. Yeah, it is. And I can even tell you that even over here, Chicago, Minnesota, millions of years ago, was under the sea. You wouldn't believe it. But what I was talking about with this rock right here and vinegar, we can find fossils in it. They might not be dinosaur fossils, but they are old ancient sea creatures. Their fossils live in limestone all over Minnesota. They don't actually live because they're dead, so they just sit there.
Before the show, we were playing this fun Minnesotan trivia game. It made me think of how important it is to look at maps. This is some from the Boundary Waters canoe area. We can see all of these lakes. Why do we have lakes? Because it is because the glaciers melted. That is why we have so many lakes here. We even have glacial lakes in Minnesota. Imagine a topographic map.
Closer lines mean that there's greater increase.
Yeah.
It's like
It's like steep.
steep, whereas the lines farther apart make
Yeah,
it flatter.
thanks for that clarification,
Yeah.
Kale. Glaciers carved out our state.
Mm.
Especially in Wisconsin, you can see those rolling hills.
Oh, yeah.
Right here, give it a shake. Do you know what this is full of mostly?
Agates.
Look at this. I call it my candy jar. Oh, I'm just wondering if you know how these agates are formed.
Yes, I do.
Does it have to do with chemistry?
Almost everything has to do with chemistry.
Exactly, and that's why space has to do with chemistry too.
Are like the plate crusts running into each other, subduction, and then pew, or
Yeah, okay. So they erupt, and in their little holes in the water, sediments
in the rock.
in the rock, sediments accumulate over years. And those layers,
Minerals. Yeah.
yeah, minerals. Those layers, that's why agates have stripes in them, if you can see. Those layers are stories in the rocks.
Agates are like onions and ogres. They have layers.
Good one, Kale.
Thank
That was a good chemist joke. Because this right here and this,
And this.
oh, that's real. I guess I'll have to keep it on here because we're scientists. These things, even rocket ships going into space, they affect our atmosphere. Could you grab that, Kale?
This.
No.
This.
That
What's
is
in
our
this?
atmosphere. I captured it. I captured our atmosphere. Okay, that is polluted.
The gases CO2, most common, CH4, and N2O are very, very, very interesting because those are our greenhouse gases. So we're talking as big as, now we're going to kind of zoom out. We just talked chemistry, and then we also talked as big as like space and orbit. So now let's talk about how our planet's orbit around the sun impacts exactly how the temperature on Earth is. Not talking about the chemicals right now.
Climate change is a negative feedback loop.
Ah.
Come in here. Are you a biologist? Yeah. Let's put our adventure caps on. Whoa. And as we pollute it, we are making it warmer and warmer. And that's the greenhouse effect. The greenhouse effect, yes, it makes it so our planet can have people on it. Because if it didn't have that, we wouldn't be able to like live. It would be too cold.
Rigid.
Rigid.
Those gases are the ones that hang out in our atmosphere. So as the sun shines its light onto Earth, it grabs the radiation, kind of soaks it in, and also reflects it back out. And that is how we get a blanket around our Earth, keeping us nice and warm and fuzzy. Lovely. The problem with that is if as we as humans emit more gases, like CO2 through pollution, we have our cars and our cows, that kind of makes that CO2 worse. That's where we're kind of going wrong right now. So yeah, because all that more gases kind of traps more heat. Oh my gosh, it's sweating. I can't even handle it. There's probably a lot of CO2 going on in the air right now. Oh, I'm so cold. There's probably not very much CO2 in the air. I just realized something wild. There's a pattern. See what pattern means? It means it's predictable. So if we realize this pattern going on right here, we can tell the future. That temperature change is quite literally because of our orbit. And that is a change that happens as the axis shifts. And so, guess what? That shows us exactly how the small changes, very small, like chemistry kind of stuff, those numbers are small, but you zoom in, that distance is actually pretty big because our planet is ginormous, and that accounts for temperature changes. Oh, it's super icy. Oh my gosh, super hot. Really warm? That can be hard. Also really cold, really hard. That is the glaciers. That's why we have more glaciers, and that's why we have the ice age. Minnesota, now we can check off the list. We were an ocean. We were covered in ice. Now, things have changed on our land. So, always changing.
We are in a negative feedback loop. Clock it. Clock it. No.
Boo. Boo.
us in a simple terms. We need to make it so the air we breathe is clean. Do you hear me? Do we want to all die? No. Okay? And this has happened before where there has been large changes in temperature, in one temperature, and two in CO2 emissions or just levels in our air, in our atmosphere. And you would not believe it, but there was multiple extinctions. Do we want that to be us? Kale?
No.
Bio-I? Space Girl me? Sabrina? No. So what are we gonna do? Team up as scientists. Science on 3. 1, 2, 3, science! Invocation.
So you might be wondering, again, Eleanor, why the frick are you bringing these cars out? I thought we were talking about the past. No, I'm not talking about the past. Because you want to know what? CO2 emissions through the roof. And those CO2 emissions, combined with the root cause of our shifting this, that is what is causing people to die. Not just people, plants, animals, living things. So as CO2 continues to rise, we can connect that to so many different extinctions, whether it's the dinosaurs, whether it's the ice age, whether it's so many other things. Are we ready to die? That's a big question, because are we ready to change?
Shame on you, everybody, who is continuously adding to the problem and not solving it. Here's proof. Right here, air quality. Oh my gosh, it's getting kind of bad over here.
Let's work to clean up our atmosphere so that we can bring it down so the greenhouse effect is a healthy blanket, not a suffocating weight. Bye. I think I'm off to space now. Shit. Oh, shoot. I don't think I'm gonna go. Wanna know why? Because I'm here to save the climate. And the planet where I can actually live on. There's no other planet. There's no planet B. Let's go. I'm here to work.
#astronaut out.